Alright, so we're going to start off with working on this acid and base worksheet. So in order to work through these, there are some basics that you have to understand. First, you have to know all the 7 strong acids and the 8 strong bases. As we go along, I'm sure I'll be mentioning some. Also, you have to know specific definitions such as dissociation reactions or neutralization reactions. Alright, so let's start with number 1. A bottle contains a 0.0063 molar solution of nitric acid. HNO3 is nitric acid. Now, A. Write the balanced and correct equation for the dissociation of HNO3 in water. So the dissociation reaction of nitric acid. Now, right here, you do have to know that nitric acid is one of the strong 7 acids, which means strong acids are defined as completely dissociated in water. So when you write that equation out, you must use a single-headed arrow. So let's write the dissociation reaction. We start off with nitric acid, HNO3, which is in an aqueous solution, will dissociate into hydrogen ions and a nitrate ion. Right? Now, please note that the fact that I am writing charges right here, the charge that I put with the positive and the negative is imperative because dissociation means that these ions are being dissolved or dissociated, split from the acid itself. So they must be in an ionic form. All right, also to be a little bit more specific, let's add the aqueous state into these ions. So that is the solution for our first question. As we move on, number B. If the bottle holds 1.5 liter of solution, how many moles of nitric acid are dissolved in the solution? Now, this is a simple matter of, do you remember the molarity equation? The molarity equation is simple. Molar concentration, or molarity, is equivalent to X amount of moles over, or moles of solute over, volumes of solution total. So, if we read from this solution right here, this question, we have up top our molar concentration. So we are just going to plug that right there, 0.0063 molar as our concentration, and equal, we do not know our number of moles currently, so that is our X. We know our volume, which is right in this question, 1.5 liter. Now, this is now basic algebra. We just want to solve for X. Now, in order to solve for X, we just want to manipulate this by multiplying 1.5 liters on each side. We can divide each of these 1.5 on one side. Then we can do the simple math here, which if you put it into the calculator, you should get 0.00945. Now, the units are careful. We have molar and liter. Now, I'm going to show you how these units disappear. This is equivalent to the X amount of moles. Now, above here, molar concentration, we understand that unit is the same as moles per liter. So we can substitute that in, leading us to write 0.00945 moles over liter multiplied by our liter, which then tells us that the liters can divide out, and you end up with 0.00945 moles for our X. And notice we got our units correct with the moles. So, this is how we solve 1b. Now, C. Calculate the pH and the pOH value of this acid. Now, right here, when we ask of pH and pOH, these both stand for potential of hydrogen ions and potential of hydroxide ions. Now, if we look at the original equation here, we only have the hydrogen ion component, which means that is the only thing that we can, at least for now, figure out. So the equation to figure out our pH comes from pH is equivalent to the negative log of our hydrogen ion concentration. Now, what is our hydrogen ion concentration? Because up top, if we are referring up very top here, the 0.0063 molar is of the acid. So this technically is referring to the concentration of the nitric acid. All right, oops, that does not look like an N. So we're going to erase that a bit and fix it a little bit. All right, now that means this is the concentration of the acid itself, but we need the concentration of the hydrogen ion. Well, how do we know that? Well, if you look over here, our nitric acid, it is a 1 mole to 1 mole ratio for our hydrogen ion, which means that the concentration of the nitric acid is equivalent to that of the hydrogen ion. So we can safely conclude that our hydrogen ion concentration is also 0.0063 molar, which means we can now substitute that into our equation, and we can type into our calculator negative log of 0.0063, oh, that looks like a 6, 0.063, and you should be able to get the pH value of 2.20. Note that this is pH. Now, once you have solved pH, pOH is simple because we understand that pH plus pOH equals 14. Now, as long as you understand this simple equation, we already have our pH component, which is 2.20 plus pOH equals 14. All right, now all we need to do is subtract 2.20 on each side, and our pOH value comes down to 11.80. And that is our pOH value. All right, on to number 2. A solution of acid has been found to have a pH value of 3.4. However, through experiments, it was found that the solution is a diprotic acid. What is the concentration of the diprotic acid? Now, first of all, here you have to understand what is a diprotic acid. Diprotic acid, using understanding the prefix di, literally means 2 protic protons. So we're talking about an acid that has 2 protons that are going to be released or donated. So we are looking at a template formula of H. Oops, how did that happen? Oops, we're going to modify that a little bit. We're looking at H2A because A can be anything, but the fact that we have 2 H's tells us that it's a diprotic acid because when you write a dissociation reaction, we are going to release 2 protons with 1 anion. All right, so the question begs right here, what is the concentration of the diprotic acid? So we define the diprotic is H2A, and what is the concentration, which means bracket H2A, because the bracket stands for concentration. So we want to know the concentration of H2A. Well, first of all, we need to know our concentration of our hydrogen ion first. Now, we have been given pH value. pH equals 3.4. Now, if you recall from our equations, our concentration can be found using pH because we can simply use the equation pH. What just happened? Everything got shifted. Yikes. Oh, I don't know what just happened. Oh well. You guys can hopefully still see it. So pH equals 10 to the power, no, scratch that. it's the concentration of hydrogen ion equals 10 to the power of negative pH. All right, that's how we get our hydrogen ion concentration. So we can just simply plug in our pH value right here. So the concentration of the hydrogen ion can come down to 10 to the negative 3.4. All right, so once we have our concentration, now according to this equation, we have just found and calculated, if you put that into the calculator, you should end up with 3.981 times 10 to the power of negative 4 molar. And this is in scientific notation, guys. All right, so we know that the concentration of the hydrogen ion is 3.981 times 10 to the power of negative 4 molar. Now, we understand that this is a diprotic acid, which means the ratio between the hydrogen ions, the protons, that are released to the acid itself is a 1:2 ratio, which means whatever the concentration of the hydrogen ions is doubled of what the original acid's concentration is, which means all we need to do is divide our value by 2. So when we do this calculation, we should end up with 1.99 times 10 to the power of negative 4 molar. And this is the concentration of our diprotic acid.